Hi everyone, I'm Philip, and I want to talk to you about cross-chain governance. So why should we change existing governance? So let me liken governance to like the government of a country, right? So we have the US and people there, they vote for parliament. Why do we change existing governance? So to liken it to like the government of a country, in a country, sure, the citizens vote and not all of them live inside of that country, okay? And I want to liken that to, let's say for the Cosmos Hub, you have the staked atom that votes in governance and that's good and that's fine. But there's an atom that's outside of the hub that's still sort of a citizen, right? It's still part of the hub and it has the best interests of the hub at heart, but it's just not on the hub and it can't vote. So for example, if you have atom that's LP'd on neutron, then that atom might want to vote on the hub when there's something important happening. Or for example, you have atom that's a stablecoin collateral. So I would liken this to the diplomats. This atom does a very important job because we want liquidity to be around the cosmos. We want atom to be used everywhere. But people don't want to lose their governance right just for not having it on the hub itself. So there's another case where you want to have cross-chain governance. So for example, the Cosmos Hub, you might know we have interchain security on the Cosmos Hub. So the hub secures neutron. And just for security, some parameters of neutron need to live on the hub. So just some parameters of interchain security are on the hub, but they impact how neutron operates. And neutron clearly wants to have a say over those parameters because neutron would like to have those parameters on their own chain, but well, they're on the hub because that's how the system works. And then on the other way around, the hub itself has a lot of neutron in the community pool, and the hub would like to use that neutron to vote in governance on the neutron chain to have an influence on what happens there. So the idea is that to introduce proposals that have cross-chain dependencies. So now it gets a little bit more technical. So the idea is you have on the host chain, you have your proposals, and you have also proposals on remote chains. So in the examples, this might be the hub, this might be neutron, and the proposal on the hub requests sort of the voting allocations from neutron in this case. And then it gets it back via IBC, and you combine the local and remote votes to get the final tally. So let me take you through the life cycle of these proposals. So these cross-chain dependency proposals. So when you create a proposal and you want this to have like a remote dependency, you create first proposal on the remote chain, and then you create it on your host chain, and you give it a list of like prerequisite proposals. These are proposals that need to be done first in order for us to be able to tell what the outcome of the main proposal should be. And you give those as the remote chain ID. So for example, here we just say neutron, and then we give it the proposal ID of this proposal on the other chain. That's how you create the proposals. And then for voting, there's no IBC communication happening. The voting just happens. Every user can vote on the proposal separately on each chain. If they have both neutron and atom, for example, they just vote on both chains. And then when you execute or when you tally the votes, that's where it gets a little more complicated. So what happens is, let's say you try to execute a proposal on the host chain, and it has some remote dependencies. You don't know about these. So what you do is you do an IBC query that asks the remote chain, hey, what is the status of this proposal? Who has voted for what? So what's the tally? What's the outcome? And you do that only, so the other chain will reject that unless it has sort of executed the proposal already. And then we do an IBC callback that stores this remote vote tally from the other chain on the host chain. And then the next time you try to execute the proposal, it will know what happened on the other chain. It will know how many tokens, what people voted for, and then you know the real outcome of the proposal, and you can act according to that. So that's the life cycle. And just as a concrete example, so if you had a proposal on the Cosmos Hub, and you were voting, so say neutron wanted to vote for some parameter change on the Cosmos Hub, you would have a proposal on the hub that essentially is blank, and it just queries the status of some proposal on neutron, and then that would be the total outcome of it. But there's other things you can do with this. For example, you could use the remote proposal to have a veto in place. So for example, the hub could vote on something, and Neutron, let's say the hub could vote on where it deploys its Neutron treasury, and then it would ask Neutron, and the vote of Neutron would only matter if Neutron vetoes. So Neutron wouldn't really get a choice in it. Neutron would just say, no, this is not acceptable to us, or this is okay for us. So there's a lot of flexibility with this principle, I think, having these proposals interact like this. And yeah, to mention the IBC calls here with the queries and then the callbacks are powered by Abstract. So I used their SDK for it, which worked great and was much easier than looking for how to do CosmWasm IBC calls otherwise. So great job on that. Yeah. Cool. And now I want to take you to, how much time do I have? 5 minutes? Okay. Okay, let's say 3 minutes. Okay, I'll take you real quick through a very, very brief code demo. So I want to show you what it looks like in an end-to-end, so in an integration test using CW Orchestrator, which was heavily recommended in the workshops. Okay, so let me show you briefly what the setup looks like. So here I'm setting up 2 chains, like Harpoon and Neutron, doing a lot of initialization here, like enabling IBC on the chains, and enabling IBC on the chains, connecting them, and then once I have the apps, so here I create a proposal that lives on chain A. So in this case, that's Harpoon. I create a proposal, and then here I tell it, okay, this proposal has no prerequisites, it's just a standard proposal. Then I create on the other chain a proposal, and here I'm going to tell it, look, you have one prerequisite proposal, and it's proposal ID 0 on this other chain, and this is the contract address that you should look at when you try to query for it. Then I'll have the app vote on chain A. So we're going to vote approve there, and that happens just on chain A. Then we are going to make the voting period pass, make the voting period on chain B pass as well, and on chain B we're going to vote reject. Okay, so we have one guy voting approve on chain A, one guy voting reject on chain B. Then when we try to execute the proposal on chain B, it's not gonna work yet. We're gonna get this error remote proposal unresolved because the proposal on chain A we haven't resolved that yet. Then when I execute the proposal on chain A, that's gonna work fine because it doesn't have any remote proposals. And now I can try to execute the proposal on chain B. This will still not work yet because it will do the IBC call to get the remote proposal tallies. And when I have waited for IBC to work, and then I try to execute the proposal again, now the proposal will execute. So here I will not have this remote proposal unresolved error anymore. And then if I look at the actual tally that I get back from the proposal, now I'll have both reject and approve in my proposal on chain B, even though on chain B only, on either chain only one of the 2 voted. Cool. So that's it. Thanks for the attention. And yeah.